self-inductance of a long solenoid. For a long solenoid, we know magnetic field is equals to B is equals to mu naught Ni. We had obtained this relation in the previous video, and where N is equals to number dense, that's number per unit length. So flux through each is Ba. So substituting the value of B, we get this. Now phi is d phi by dt, that is equals to this, that is flux into total, and this is give the total flux. Then we have to calculate from here that phi, as we know, phi is directly proportional to I and phi is equals to Li. Now comparing this with this term, we get L is equals to mu naught N square A upon L. So this is the self-inductance expression for a long solenoid. Then if a rod permeability is is inserted, if a rod of permeability mu in the solenoid is inserted, it means if this is a solenoid like this, if a rod is inserted with the permeability of mu, in that case its inductance will become mu is equal L is equals to mu time of that. So this will become mu R time L. So it will increase. So next question is self-inductance of an air core is increases to this on introducing iron core into it. What is mu R? We know that L dash equals to mu R L. We have to calculate mu R, that is L dash by L. Substitute the value and calculate the answer. Next is figure show an inductor and a resistor are connected in parallel through a switch. The resistance R is same as that of the coil. Make an identical bulbs are put in each arm of the circuit. Which of the bulb light up bright when it's closed, and which will the two bulb will be equally bright after the same time? We have to check that. As we know, first one is inductor, second one is resistor, and inductor always oppose the cause of its production. So B2 will glow more due to the self-inductance in the coil. Same brightness after, because once the time has passed or long time has done or passed away, then they will acquire steady current and glow with the same amount. Next is mutual induction. So if current is given to one coil, due to which flux with this coil changes, as a result flux with also get linked with this, and induced EMF get produced in this coil. So same, phi is directly proportional to I, but proportionality sign is M. M is the mutual induction. Again substituting the value, we get M is equals to minus E di by dt. Unit is again Henry. Now mutual induction for two long solenoid, we have to calculate that expression. By solving that in the same way, we will get here mutual induction is equals to mu naught N1 and 2 A upon L. This is the formula for mutual induction. This is for one and similar for the second one. So if we can also calculate further, a circular coil of radius 8 cm turn 20 turns and rotate its vertical diameter with angular speed of 50 radian per second in a uniform horizontal magnetic field. Uniform horizontal means this is BH. This is BH. Obtain the maximum EMF induced in the coil. Calculate the maximum value of I in the coil. What is the loss due to heating? Average loss due to heating and average EMF you have to calculate. As we know, EMF is equals to this formula that we have calculated earlier. So for maximum, we know sin omega t equals to 1. By substituting rest of value, we get this. And for the average formula, this is voltage square by resistance. By substituting the value, you will get average power here.